Hello, dear students. Today we are starting Unit 3 of soft computing, and this unit is related to fuzzy logic. Here in this fuzzy logic unit, we will be covering some very basic features of the fuzzy logic. Then we will discuss classical set, rather we can say crisp set, and then the fuzzy sets. Then further we will try to understand the various kind of properties of the fuzzy set and the variety of operations which can be possible on fuzzy sets. Further, then after in this unit we will discuss something related to the fuzzy relations and the variety of fuzzy operations of the fuzzy relations. So this all is about the third unit. And dear students, I just want to tell you that this is the simplest unit of this complete course. Course itself is soft computing, and fuzzy theory of fuzzy logic is one of the tool of this soft computing. Friends, as you already know, that soft computing is just not like the your regular computing. You have a lot of regular normal computing techniques. So this is not known as the computing technique, it is known as a soft computing. So a lot of technologies are there in the soft computing. One is the neural network, which you have already covered in first unit and second unit. In this third and fourth unit, you will be covering about the fuzzy logic. And finally, we will have a discussion of genetic algorithm in unit number 5. So this is the most important part of the soft computing, and this is fuzzy logic. Here, once you will be able to understand the concept of fuzzy logic, then also you will be implementing this logic in defining different kind of fuzzy rule and fuzzy inference system. Friends, you will see that nowadays we have seen Japanese industries have done a lot of work in fuzzy theory. Jade, Mr. Jade was the whole soul creator of this technology. He proposed the concept of fuzzy theory, and he had done a great contribution in this field. And now gradually all the different countries around the globe, they have adopted this technology, and they are using this technique in a variety of jobs. You can see that nowadays a lot of different electrical and electronic appliances which we are using in our household applications, mostly all of them are using fuzzy inference system for better operationality in the different conditions. Like if we see our washing machine, our refrigerator, our air condition, lot of other different electrical and electronic equipments are there which we are daily using in our life, and most of them are using fuzzy inference system in themselves. They are built in, and they provide the better operationality to these components in different conditions. So let us look over this, see how it complete works. I'm just starting the basic concept of the fuzzy logic in this lecture, and then further we will discuss something related to the different properties and the functions which we can done on the fuzzy logic. Friends, the meaning of fuzzy means vagueness. Fuzzy itself means the vagueness. So it seems very typical to what we are going to study. We are going to study the vagueness, but practically when we discuss something, so a lot of vagueness is there in our own assumption, in our own inferences. Nothing is there in the nothing is crisp in the real world. Crisp means when we have something fixed. Like you have already studied the classical set theory in class 11th and 12th, and that theory is also very easy. Within that theory, you have used the concept of boolean logic. When we talk about a classical set, so we can say that this set can accommodate some elements in itself, or it will not accommodate some elements which are available in the universe of discourse. Like, say for example, I'm saying you that there is a class of some students, and within that class we make a crisp set, rather we can say the classical set, and this set is, say, for the name of a student who scored more than 85% marks. So in the examination, when examination are conducted and results are declared, some of the students scored more than 85% marks, and some student who could not score the 85% marks. Now, talking in the context of the set, when we say that make a set of those students who score more than 85% marks, there are some fixed number of students in the set. So suppose total 10 students are there who scored more than 85% marks. So in that set, only 10 that specific student will be there. Rest all the other students will not be accommodated by the set. We do understand that all the other students are in the universe of discourse. So here, in this context, the universe of discourse is the entire class, the student of the entire class. But when we say set of a student who score more than 85% marks, then this set will contain only those students, those specific students who succeeded in scoring more than 85% marks. Here, the boundaries of the set is crisp. Crisp means with determination, we can define something. That means here the boundaries of the crisp set, rather we can say the classical set, is fixed. But say for example, on the other hand, I just tell you, okay, make the set of tall student of the class. Make a set of the tall student of the class. Now, it is the different example. Now it is the example where vagueness is coming in the picture. Vagueness means it's a real life problem. When I tell you that you please make a set of the tall student of the class, so how you can understand which one student is tall and which one is short and which one is of the medium height? So it depends on the different kind of the perceptions of the person those who are dealing with the problem. So here the uncertainty comes in the picture. Here the vagueness comes in the picture. Here the imprecision comes in the scenario. So due to all these things, they are not the sharp boundaries of the set, and these type of sets are known as the fuzzy sets. Say for example, if I make a set of the tall student of the class, up to my understanding, I am considering those who are having more than 5 feet 6 inches height. I am considering that they all are the tall. So I make the student those who are having good height, more than 6.5 feet. Say for example, if this task has been asked to perform by some other person, and according to his perception, he make a set of those students who are taller than 5 feet 8 inches, and according to his perception, the membership, rather we can say how strongly a person belongs to a set, may be different. So here you are seeing that the different kind of vagueness, fuzziness, and the imprecision comes in the picture. These type of sets are known as the fuzzy sets. In this entire theory, in this entire journey, we will be discussing only these two things. One is the classical set, rather we can say the crisp set, where the boundaries are sharp and we are very much certain, we are very much definite, and we can easily determine the boundaries of the set. Rather we can say, we can easily tell which are the elements which will come under the boundaries of the set and which will not be accommodated by the set. So we can be very easily understand in the case of the crisp. But on the same hand, I have given you an example of the fuzzy set, where imprecision is there, where uncertainty is there, where vagueness is there. So in this entire journey, we are discussing all these things. Now friends, I have discussed some things with you. One very important thing is the uncertainty. See, from very old days, there is a full flash technique, that is the probabilistic theory. In mathematics, we are having a probabilistic theory which deals with all these type of situations where probability occurs, where uncertainty occurs. So you can say, sir, when uncertainty is there, so there should not be any kind of the worry, because we are having one very good tool, that is the probabilistic study. So with the help of that probabilistic study, we can solve the uncertainty, we can remove the uncertainty, and we can solve any kind of the problem. But here I am telling you that the nature of uncertainty is different. Sometimes it depends on the scenario to scenario. Sometimes when we achieve the uncertainty due to the randomness of the nature of the event, then only that type of uncertainty is dealt by the probabilistic theory. But when the uncertainty is occurred due to the imprecision, due to the due to not having the complete knowledge about the situation, due to the vagueness, then that type of uncertainty is dealt with the help of the fuzzy theory. I'm just giving you an example. Say for example, when you are tossing a coin, it's a random process. All parameters are fixed. The person who is tossing, it's fixed. The environment in which toss has been done, that environment is fixed. But this process is random. Either head can come or tail can come. So it's a random process. But here uncertainty, we are not certain कि either head will come or tail will come. So uncertainty is there definitely, but this uncertainty is only due to the randomness in the event, random nature of the event. But if uncertainty is coming in the scenario where we are not having the complete information of the system, or imprecision is there, or we are collecting the information from different sources which are giving the different type of information, or some vagueness is there, and in such way if uncertainty is coming, then we are having the fuzzy theory which will help us to solve these kind of things. So till now friends, I have discussed something related to you. One is the uh, fuzzy concept, the meaning of fuzzy, the person who proposed the concept of fuzzy theory, Jade itself, Dr. Jade itself, who proposed the concept of fuzzy theory. And another thing is uncertainty and the different kind of scenario where we have different tools to deal with the different situations of the uncertainty. One is the probabilistic theory, another is the fuzzy theory. Friends, have you already seen that this soft computing is also sometimes some of the author have also named it as a computational intelligence. This soft computing term has been named by some famous author by the computational intelligence. So you can use the computational intelligence also, but it is not so much familiar among the community of the researchers. Most of the researchers are dealing all these things with the soft computing in the domain of the soft computing. So now onward, we will also discuss all these things in the domain of the soft computing. Right. So I have already shown you here that the random processes are there which may generate the uncertainty scenario, and this is dealt with the help of the probabilistic theory. Another non-random processes are there due to which if uncertainty has been achieved, then that uncertainty is dealt by the fuzzy set theory. Right. Here friends, I'm showing you that this uncertainty, it can be due to the partial information of the problem. Say for example, we are not having the complete information of the problem, then due to this reason uncertainty may be there. Or suppose you are gathering the information from the different sources which are not reliable, so imprecision can be due to this reason also. Or you are collecting information from more than one source, so due to these reasons uncertainty can be there. Now friends, the fuzzy set theory is an excellent tool to handle the uncertainty arises due to vagueness, which we have already discussed. There are some features, as I already told you, Japanese have implemented this fuzzy theory in a lot of the domains, lot of the areas. Like I told you that in different kind of washing machines and different type of air conditioners, refrigerators, not only these but also with the industrial equipments also, with in the aviation field also. Like there is an aircraft, so there can be one inference system who can give us the correct picture by considering the different kind of environment about the outside temperature, humidity, wind speed, and other information. According collecting after all this information, one inference system can help us and can give us the right information by which way the aircraft must be landed, like which way washing machine, the revolution, the speed of the revolution of the machine washing machine should be there. So uh, Japanese has worked a lot in these domains. Now, coming on the fuzzy set and the crisp set. Crisp set, again I'm saying that the classical set, which you are already aware very well. So, one logic works behind the classical set, and that logic is the boolean logic. You know it very well in class 11th, 12th, or even in first year also. You have gone through with the concept of the boolean logic, where the different theorems are there which you follow for the boolean logic. In a similar way, when we are dealing with the fuzzy sets, as I have already given you an example of the fuzzy set, here a different logic works, and that logic is just like a similar logic of the boolean logic, but its name is the fuzzy logic. So for crisp set, boolean logic works in the background. For the fuzzy set, fuzzy logic works with the background. In the boolean logic, we are having two answers only of any kind of the problem: yes or no, true or false. Either yes, no, or true or false. That member either will be accommodated by the set. Its answer will be either yes or no. Either one member can be in the set, or it may not be in the set. So it's very easy. So it's a boolean logic. It's a crisp logic, and sometimes we can say that there are some crisp statement. We generally say don't give me the vague figure, don't give me the vague information, don't give me the vague statement. We generally tell all these things in our practice to each other. Vague means which is not certain. So if I tell to some of my colleague, okay, I will meet you there at 10 p.m. That's a crisp information. It means I'm deciding something to meet my friend at some specific location at some specific time at 10 p.m. It's a crisp information. It's a crisp statement. And say for example, I'm saying something something to my friend. Okay, you meet me at that specific point, almost approximately at 10 in night. Approximately 10 in night. So there is a vagueness. So I'm not fixing, I'm not determining, I'm not freezing the time at what time I will be going to meet my colleague. So this is the fuzzy statement. So as I discuss here, one example of the crisp statement: the number of students in a class having more than 80% marks is equal to 40. I'm giving a statement that there are only 40 students in a class who scored more than 80% marks. So I am very much deterministic. It's a crisp information, right? Another example is number of employees, those who are working in the morning shift in a company, is equal to 200. So I know it very well. There are 200 employees are there. Those who are coming in an organization in the morning shift, they are fixed. I get an information from the HR department. So once the information is complete, there is no imprecision, there is a sharp boundary, then that type of information is known as the crisp information, crisp statement. Now on the contrary, just consider another example. Say that example is Ram honest? I'm saying, I'm telling you a thing, and it's a question to you: is Ram honest? So it means there is some degree of honesty comes in the picture. Up to some extent, Ram may be honest, or he may be not honest. He may be perfectly honest. So here the degree of honesty is changing in different perspective. So here vagueness is there, here uncertainty is there. That is why I am saying that this statement is a fuzzy statement. This statement is the fuzzy statement. So you can say the answer of this statement is not definite, not fixed, like yes or no. Ram is honest, we cannot say yes, Ram is honest, or we cannot say no, Ram is not honest. Ram may be honest, Ram may not be honest, Ram may be honest up to some extent, Ram may be honest for some specific person, Ram may be dishonest to some another person. So if I am collecting the information from different sources and making a kind of the set, so everybody can give the different kind of information. So accordingly we can say, one knows Ram, a variety of answer may comes like very honest, extremely honest, honest, most of the time, dishonest, etc. right? Like I told you one example few minutes before, that if I ask you to make a set of tall students, so what in that case what you can do, universal discourse is the class itself. So for example, there are 100 students in a class, so we can say that in that universe of discourse there are 100 students. In that case, when you are asked to make a fuzzy set, all the 100 students will come in the fuzzy set. There is a very basic, very important universal rule is there. Everybody is related to everybody. You will see this universal statement when we will be dealing with the fuzzy relations. But when I'm giving an assignment, okay, make a fuzzy set, make a fuzzy set of the tallness. So in that thing, what you can do, you can include all the elements of the universe of discourse in the fuzzy set, and that fuzzy set is the tall students of the class. The name of the fuzzy set is the tall students of the class. In that fuzzy set, what you can do, you can accommodate all the elements from the universe of discourse with a different variety of degree of membership. Rather, we can say with a degree of association of this set. Say there is a student who is having height 6 feet 4 inches. According to my perspective, he is the tallest student. So I'm saying that here its degree of membership of this set is 1. And suppose there is a student whose height is 5 feet 10 inches. So for example, I'm giving its a membership value 0.75. So up to my perception, I'm saying that the degree of membership of this specific student is 0.75. The degree of association of this specific student in the set of tall student is 0.75. Say for example, there is a girl whose height is 5 feet, and say for example, she is the shortest student in the class. Now in that case, what I can do, I can put that its degree of association of in respect to this set is 0.1, because I'm not considering that girl as a tall student. So by this way, what was the purpose of mine to discuss all these things with you, that there is some kind of association of element with the fuzzy set, and this association is done with the help of the membership value. So here comes a very important thing in our picture, that each and every element in the fuzzy set, they itself have some membership value. We will discuss it later on with more detail. Let's come again on the same thing, that you already know that what are the crisp set. You have already made lot of sets. You know what is a set. Set is a collection of element which has similar kind of property in a particular context. Here an element from universe of discourse will either belong to set or it will not belong to the set. So here the answer is yes or no. Here the crisp logic works in background. And the crisp set can be represented by variety of ways. The representation of set is done with a capital letter. With the capital letter we denote a set, and all the elements of the set, they are represented by the small letters. It's one another way to represent a set. Say for example, suppose it's a way to represent a set. Here what we are doing, we are encapsulating the different element of the set in curly braces. It is a way to represent a set. But say for example, suppose the number of elements are very large. There are a lot of elements in the set. So in that way, how we can represent a set? Set can be represented like this. A is a set, capital A. It is representing a set. Here X is small. It is representing the different elements of the set, and here pipe symbol is there, and some condition is there. That means the set A will contain all those elements from the universe of discourse who will satisfy this specific property. So there are three things. One is the set name, which has been represented by capital letter. One is X, which is represented by small symbol, and there is one statement, one condition is there which is represented by PX. There is one universe of discourse. So I am saying that set A will have all those elements X from the universe of discourse which will satisfy the property Px. Let's say another way to represent a set. Another third way to represent a set is the Venn diagram. You know it very well. So this is the complete box. It's a box, and this is the universe of discourse. Some authors are representing it by capital U. Some authors are representing it by capital E. You can use any one of them, the notation. So this is the complete universe of discourse. Universe of discourse, understanding the concept of universe of discourse is very important. When I am talking to make a set of students who score more than 80% numbers, here the universe of discourse will have the students, all the students of that class only. Here the universe of discourse will have all those elements which are the students of the class, and this set A will keep only those elements who scored more than 80% marks. So please keep remember this thing, that what is this universe of discourse? In the different context, this universe of discourse will change. Okay. Now let us come on the concept where the membership information will come. The membership information says that either one element X, which is the element of the universe of discourse, either it will belong to set A or it will not belong to set A. I told you earlier also, there is a crisp information. Now, the another thing is the cardinality of the set. This cardinality of the set, it means that if how many elements are there in a set, that number is known as the cardinality of the set. Here, say for example, there are 4 elements, 4, 5, 6, 7, there are 4 elements in that set. So we can say that the cardinality of the set A is 4. One another thing is there, family of set. A set whose elements are set themselves, then that set is known as the family of set. Its example is like this. Next, very easy thing, null set or the empty set. Null set is represented by 5 and the cardinality of the null set is 0. Singleton set, the set which contains only one element is known as the singleton set and its cardinality is 1. Now the subset, the concept of subset and proper subset. Subset is represented by this sign and proper subset is represented by this sign. When equal sign is there, to treat it as a subset. This is the subset, right? To take here and consider it with an example. Say for example, we are having a set A, capital A, where A, B, C are elements, and there is one another set B, C. So we can say this is a subset of capital A. It is a subset of capital A. Now suppose there is one another set which is having element A, B, C, and we see that already set A accommodates all these elements. So this set is the proper subset of A. Proper subset means when all the elements are there within this set. Say for example, we are having a set P having element 1, 2, 3, another set capital Q having element 1, 2, 3, 4, 5. Then P is a part of Q. What we can say, P is a part of Q. Yes, 1, 2, 3 are here, and here 1, 2, 3, 4, 5 is there. So what we can say, P is a subset of Q. That is, every element of P are also present in Q. So here P is a subset of P also. Yes, this statement is also true. P is a subset of P also. If there is some question where P is a set and we are writing that P is a subset of P, yes, okay, its condition, its statement is true. Q is a subset of Q itself. Yes, this condition is true. But suppose we are having one set C having element 4, 5, 6, and there is one another set that is 4, 5, 6, the same element. We are having the same element, and we are representing C is a subset of D. No, C is a proper subset of D. Now come on the superset. In the same way, you can understand the concept of the superset also. Power set is a set of all possible subsets that can be derived from the given set. Say for example, there is a set 1, 2, 3. So how many different kind of sets, subsets which can be drawn from A, they make the power set of A. So power set of A is represented by PA. Here 5 is one set, 1 alone is one subset, 2 alone is one subset, 3 alone is one subset, 1 2 can be made as a subset, 1 3, 2 3, 1 2 3. So they all are the part of the subset which we can make from the given subset A. So the cardinality of the power set is 2 to the power mod A, cardinality of the A. Say for example, suppose we are having 3 elements in a set, then the power set will have total 8 elements. So now friends, by this way I just tell you some of the concept of the crisp set, fuzzy set theory, uncertainty, how to deal with all these things in this first lecture. In the next lecture we will discuss some of the relations and the properties of the fuzzy set, and further we will try to make a clear-cut relationship between these type of operation and properties with the fuzzy set system. Thank you very much.